Hi, everyone. I'm Ben Goodger, and I lead the web platform team at Google. Welcome to BlinkOn 16. BlinkOn is always an important moment in the Chromium calendar. It's a chance for us to come together and learn from each other, what's been going on, what's new and in development, and a chance to go deep on some amazing tech that the community's been building. Chromium is a super valuable foundation for innovation with broad-reaching impact. With that, I'd like to offer thanks and to those who are hosting sessions over the next couple of days, and thanks to everyone who's participating, whether it's just to listen and learn or to help move the discussion forward. You're making the web better for developers and users around the world. I hope you have a great time. With that, let's get started.
Hello, everybody. Thanks so much to Ben Goodger, Web Platform VP here at Google, for such a warm welcome to BlinkOn 16. I'm Tab Atkins-Bittner, web standards hacker at Google. You might remember me from the last BlinkOn or from interactions in the standards world. I'll be your MC for the next few days. A few quick notes before we jump in. First, if you haven't already done so, you can turn on automatically generated captions by pressing the CC button at the bottom of your screen. There'll be human-generated closed captions added to the recorded sessions on YouTube after the conference on the BlinkOn YouTube channel. Second, to help everybody know how to refer to you during networking and chat, please add pronouns and corporate affiliation to your name. Just a little, here we go. Parenthesized after your personal name is great, like you should see right here. Now, if you've previously attended BlinkOn, you should know that the next 2 days will be filled with interesting talks, insightful discussions, and great networking opportunities. So without further ado, let's get started. First up, the BlinkOn keynote presented by Daniel Clifford and Peter Beverlew.
Hey there, good morning, good afternoon, wherever you are. My name is Peter Beverlew. I'm a tech lead and manager leading the Android embedded experience team as well as the mobile installability teams at Google. We're based across several countries and we're responsible for all the ways our users interact with the web on Android outside of a browser. Over to you, Dano.
Thanks, Peter. Hi, I'm Daniel Clifford. I'm a principal software engineer in Munich, leading the development of part of Chrome's web platform. My international team is responsible for V8, Chrome developer tools, developer insights and activation, and web platform trust and safety. First of all, I'd like to extend a warm welcome to everybody who is watching. Thanks for coming. Thanks for tuning in. To kick us off, I'd like to first share a few thoughts about optimism. The last couple of years have presented many challenges for many of us in many different ways. However, I'm pretty optimistic about the future. To start with, there is hope that soon we might be able to have a hybrid BlinkOn that could include face-to-face interaction. That's something I am really looking forward to. But the web platform itself gives me more reasons to be optimistic. Among other things, my team works on WebAssembly and tools for WebAssembly. At the end of last year, Adobe announced they will bring Photoshop to the web using these technologies. I found this super exciting personally, not only because of my team's involvement, but because this was evidence that it is still possible to radically innovate with the open web. It was a reminder to me that the open, collaboratively built web platform that my team and you all together is still full of new and wonderful surprises. We have only seen the beginning of an ongoing journey with the web based on open standards and open collaboration. I'm confident that the open web's future will bring many more innovation and innovative moments like the Adobe announcement. Now more than ever, the open web has a future where only the sky is the limit. One amazing aspect of the open web is its richness and diversity. It is a platform where everyone's voice can be heard, regardless of who they are and where they come from. So let's take a moment to acknowledge the richness of backgrounds of those who actually build the platform, and that's you all. People attending BlinkOn are from all over the world. It's great to see people coming together from so many different countries. While most of the BlinkOn attendees reside in North America, there are 25 different countries represented. Who's present today is one way of looking at our community, but it's also interesting to look at who's making Blink contributions across the entire project. Across all Chromium-related repositories, Igalia, Microsoft, and Intel have made the largest contributions by commit count. Individual contributors, when taken together, also represent a significant chunk of non-Google contributions. Zooming in just a bit more, just to Chromium contributions, Igalia definitely stands out. They enable organizations who don't have browser teams to commit to the Chromium project. Taken all together, in the past 6 months, we saw 161 intent to Blink messages to Blink Dev, and 57 of those announced an implementation, 32 experimentation, 78 an intention to ship, and 8 of those intended to deprecate or remove a feature. It's clear that you have all been super busy over the last 6 months. Thank you for contributing to the Blink project and for being part of this community. I'm gonna have it over to Peter.
Thank you. Yeah, tens of thousands of commits from dozens of organizations and many more individuals. Let's start by zooming in a little bit more by highlighting a few specific members of our community. Next slide, please. First up, Igalia. Igalia has made many contributions to Chromium and related projects all across the board. Earlier this week, they sent a long-awaited intent to ship message for the head pseudo class, and later on during BlinkOn, we'll be having a session to discuss the shipping plans for MEFML. Many of their achievements will be covered in today's presentation. Microsoft has also made very extensive contributions spread out across so many different functional areas. They've delivered improvements across the board, introduced new capabilities such as scroll-linked animations in the Ink API, and worked on many memory and stability improvements. Intel has focused on introducing new capabilities to Chromium and the web platform across the board, all with an eye towards further empowering the web as an application platform, very much in line with modern computing platforms. And finally, almost a quarter of the non-Google commits were made by individual contributors. There's really way too much to mention here, but a few contributions are highlighted on this slide, with there being countless more towards Chromium's functionality, compatibility, reliability, and security. I think the Deno statement of saying that you've all been super busy definitely was an understatement. Thank you. Each and every one of those contributions is very much appreciated, and they all benefit everyone who is part of the Blink community.
Let's dive deeper into what's happened over the last 6 months. We'll start with ecosystem changes and code health. A superpower of the web is cross-browser interop, but interoperability has consistently been a top developer pain point. For the first time ever, the major browser vendors are working together to address that with the Interop 2022 compatibility benchmark. It is supported with input and review by Apple, Boku, Google, Igalia, Microsoft, and Mozilla. Thank you to the people who have already signed up to work on this topic. The more individual Blink contributors who are passionate about interop and are willing to invest their time to improve it, the better. There's still plenty to do, so please help. For the health of the ecosystem, it's important to be able to get feedback during experimentation and optimize for smooth feature launches. Origin trials will be enabled for the Android web view starting in Chrome 102, which will give insights before launch that were previously hidden. Performance continues to be an area of focus. With the help of optimizations in V8 and elsewhere in Blink, we achieved the highest speedometer score ever for Chrome 100. WASM-GC is making progress too. Java, Dart, and Kotlin are all making progress towards using WebAssembly to run their languages on the web too. All of your work doesn't just help developers. Ecosystem contributions that enable Core Web Vital improvements saved a total of 1,000 years of users waiting for pages to load in Q4. That's a lot of saved time. Of course, some of the most impactful contributions aren't new features, but about making our existing functionality work better for users and developers. Since last BlinkOn, you have all fixed nearly 5,000 high-priority bugs. Thank you for that. We use start counts as one indicator of importance to developers, and here are the 3 fixes with the most developer appreciation since last BlinkOn. Great work, and thanks again. Making ourselves more productive is also super important. There's been lots of progress on a number of code health initiatives. You can help by grabbing bugs yourself from the code health rotation bug list, and you'll see later in the speaker notes how to actually look those up.
Excellent, thank you. Next up, let's check in on the progress we've been making in improving the user experience. Last year, we ran an origin trial for shared element transitions, and we learned a lot from it. As a result, we've changed the API to give developers more control over the animations that they create, with a second origin trial planned to start in milestone 103. One of the Privacy Sandbox APIs that we're testing in Chrome right now is the Federated Credential Management API. This is a new way for browsers to support logins with any identity provider that is not reliant on third-party cookies. This enables users to have a more safe and a more easy way to log into different websites. We also shipped the second version of the Digital Goods API. This API facilitates in-app purchases in web applications, making it possible for web apps published on the Google Play Store to accept payments for digital goods. Fluid and Flexible strives to enable rich web applications in CSS and has been focusing on creating polyfills to drive early adoption of new functionality. The container queries and scroll-linked animation polyfills are good examples of this, whether CSS compliance is tested against web platform tests. Scroll unification has been a long-running effort to move scrolling logic into a single code path, which reduces the cost, the complexity, and the brittleness of our implementation. This has greatly accelerated our investments towards scrolling interop in 2022. There also has been great progress on the instant loading front. BFCAS improvements were landed, and pre-rendering, web transport, and early hints launched as new functionalities. We also continue to be more effective in suppressing loud permission requests that are unlikely to be granted by our users. Since shipping the initial version in the second half of last year, we've been working hard on enhancing the privacy properties of this feature and improving and creating a more consistent and polished user experience. We have shipped fully on-device predictions for geolocation permission requests, and a new quiet chip permission UI. We also introduced interaction to next paint, or IMP for short, as an experimental field metric that assesses responsiveness. IMP logs with the latency of all interactions throughout the lifecycle of the page. Next slide, please. Thank you. For our users on Android, we've been tweaking the user experience offered when installing web apps to a device. Install complete notifications increase the awareness for our users of the newly available installed experiences.
Now, I'm pretty excited to tell you about what is new for developers. Peter mentioned IMP, and speaking of it, we've added tooling support to measure it. You can now find support for the new metric in Crux, Lighthouse, PSI, and the Web Vitals extension. There's lots of new functionality to help developers optimize performance. A new BF cache tab was added in DevTools. Partially presented frames can now be debugged in the performance panel, and there's so much more. Smoothness and responsiveness alerts are now available in Perfetto, making it easier to visualize and locate smoothness affecting events. DevTools now has a selection of new functionality targeted at designers. For example, there's new support for container queries, cascade layers, and user adaptive emulation. Improvements in the area of debugging include WebSocket throttling, performance improvements when debugging large WebAssembly applications, and feature additions to the application panel. And on the testing front, we've made improvements to browser automation through contributions in WebDriver and the new WebDriver BiDi standard. And I'd like to especially thank Microsoft for their help there.
Great, thank you. Let's check in what's been happening in the rendering and graphics fronts. Quite a lot, actually. First off, Microsoft and Google have been working on a new fragmentation engine, which we're beginning to roll out for core block fragmentation in 102 and follow up with flex and grid fragmentation in milestone 103. This fixes a ton of bugs reported by web developers. Similarly, blocking inline fixes a long-standing architectural issue by solving numerous paint effect bugs. Cascade layers landed in M99. They enable more explicit control for CSS files to prevent style specificity conflicts. The hidden until, found, and before match features are available starting 102, and they allow finding page to work for hidden regions and enable hidden content to be accessible for search engines. The inert property is a global HTML attribute that simplifies how to remove and restore user input events for an element, including focus events and events from assistive technologies. A shout out to Igalia for taking the lead in the implementation. Direct rendering display compositing plans to launch on Android in 102, followed by the other platforms. This significantly improves smoothness and reduces jank. Support for white color gamut has been added to 2D Canvas and WebGL, and Blink's internal color representation has been updated to match. We already have a prototype of HDR support across the different graphic surfaces. Many new features have been added to the Canvas 2D APIs as well, allowing it to catch up to CSS, streamline developer ergonomics, and improve its performance. The Text Layout API allows rendering of paragraphs of text on a canvas, and it's now possible to create graphics layers, which enable filters to be applied once to multiple drawing functions. While WebGPU is still in an origin trial, lots of specification, implementation, and conformance testing work has brought us ever so close to the WebGPU version 1 milestone. On top of that, we've been working on a WebGPU backend for free.js and continued our collaboration with Apple for supporting Metal in our WebGL implementation on macOS.
Security and privacy remain core concerns of the web platform. Let's talk about some of the latest developments on that front too. Partition Alloc Everywhere launched on macOS. It's a security-hardened allocator that enables security features like Miracle Pointer. As a bonus, using Partition Alloc Everywhere has led to a 24% total memory usage reduction in Chrome Stable. Miracle Pointer offers a new way to protect against use after free exploits. The so-called big rewrite that paves the way for using Miracle Pointer has been completed. Co-op Credentialist launched. We're prototyping anonymous iframes and co-op pop-ups to ease pain points to cross-origin isolation adoption. Origin Agent Cluster by default will ship later this year. Same with pre-flight checks for private network access. We will launch Sanitizer soon. We're super excited because Mozilla has also implemented the API in Firefox. Work on the Privacy Sandbox progresses. As a reminder, the Privacy Sandbox aims to create tech that both protects people's privacy online and gives companies and developers tools to build thriving digital businesses. In addition to a whole bunch of Origin trial features that have moved to stable or have been introduced in beta, we've launched a deprecation trial for user agent reduction and launched user agent client hits, which aims to really fundamentally fix the pain of the user agent string.
And of course, you've all been waiting and been very busy adding amazing new capabilities to the platform. Let's have a look. The Local Font Access API allows you to access the fonts installed on the user's device and obtain low-level information about them. It's shipped in milestone 103. Web apps can now be registered as system-wide file handlers using the File Handling API, which became available in milestone 102. Microsoft has driven the Window Control Overlay API, which enables developers to customize the title bar next to the window controls. This gives web apps a lot more control over the integrated user experience. In M100, we introduced a multi-screen window placement API, enabling developers to identify the connected displays and position their content on specific screens. Next slide, thank you. The Handwriting Recognition API allows you to recognize text from handwritten input in real time. It's been available since '99. The Web Transport API is offering a low latency and bidirectional messaging platform. It's been available since M97. URL protocol handlers let installed PWAs handle links that use a specific protocol for a more integrated experience, and it's available since M96. Many thanks to the folks at Microsoft for driving this work. Launching access handles for Origin Private File System marks the exciting conclusion of a long effort called Storage Foundation, which allows efficient access to local file systems. The completion of this work has enabled the web for a whole new class of use cases, such as Adobe's Photoshop. This API is shipped in milestone 102. That's a huge amount of improvements that we all drove over the past 6 months. The web has made some huge leaps in that time. With all the new capabilities and graphics rendering modes, we've made the web more complex, but we've also actively enabled and empowered developers to take it and innovate in entirely new directions. With all the performance improvements, we've made it faster and easier to use, and we went beyond that. We introduced entirely new mechanisms to introduce, measure, but also understand responsiveness. Between all the testing, interop, and security work, we've increased the web's compatibility and made it more resilient than ever before. It's super exciting to see that the other browsing engines also continue to invest in this. And we did all of this without leaving anyone behind, introducing many more improvements in developer tooling, in developer insights, and in the overall developer experience. I've been working on creating a web app myself recently, and the best way to summarize my own experience is by calling it fun. Then I mentioned optimism, and I think that the Blink community is really the community that's giving people a lot of reason to be optimistic. Thank you so much, and we hope that you have a great time at BlinkOn 16.
Thank you.
That was a really exciting review. Thank you so much, Dano and Peter. So next up, we're going to go into the lightning talks. Please say hello to Kentaro.
Hi, so I am Haraken. So welcome everyone to the BlinkOn Lightning Talk session. Are you excited? So as always, I want to celebrate the Lightning Talk session with a party pop. So I have a handkerchief this way. So 1, 2, 3. Blink on. Amazing. So I got a party pop. Okay, so 1, 2, 3. Yay. All right, so today, we have 13 lightning talks. As always, I asked all the speakers to insert one point where they can get a storm of applause. Please find that point and send a round of applause and heartwarming messages using the text chat. So the speakers are also watching this session. All right, so let's get started.
Hello everyone, I'm Rahul from Microsoft and I'd like to demo a feature that I was working on recently. So this feature is about ensuring that elements with position fixed do not participate in elastic overscroll. For example, in the YouTube web app below, you can see that the fixed header currently moves during overscroll, and the work that I did prevents that from happening, and that in turn enables us to build rich user experiences for web apps. So this is a high-level architecture for the implementation. During pre-paint tree walk, we set the compositing region to k-fix to viewport on the paint property tree builder context. The paint artifact compositor then stashes the viewport property IDs of the elasticity transform on the transform tree. We then create the transform node in the compositor for the corresponding transform paint property node. And finally, we translate the local transforms when we overscroll and then we inflate the clip. So ultimately, this is how it will look like. Here we see a before and after for 4 different web apps. You can see that the fixed headers stay put when we overscroll, and this should actually work in all scroll directions. So in closing, I'd like to thank the code reviewers, Xianzu Wang and Philip Rogers, for all the code reviews. I'd also like to thank the CSS working group for getting this thing spec'd and discussing all the issues. I'd also like to request all of you to please self-host this feature and file bugs. This feature is dependent on 2 flags, elastic overscroll and fixed elements don't overscroll. And if you have any questions, please reach out to me at arkeri@microsoft.com. So that's all from me for now. So thank you for your time, and I hope you have a great day.
Hello, I'm Byung-woo Lee in Igalia. This is a quick summary of the HAS implementation. Igalia have been investigating and implementing the HAS pseudo class since before 2021 thanks to the support from IO. Since we announced to start, we have merged more than 30 CLs and had some communications in many channels. We finished to support HAS in the snapshot profile at an early stage. And for the live profile, we broke down the implementation into very small pieces so that we could check as many issues and risks at each stage. Since the feature was enabled behind the experimental flag, we've been working on improving performance and quality. So what is the current status of HAS? Functionally, Chrome should support all cases except these limitations behind the experimental flag. So please use it and report any bugs or missing cases. It provides reasonable performance. The processing time increases almost in proportion to the number of elements in most cases. Even if we use non-subject HAS for the heavy operations like query selector all, it scales linearly. And it is same for more complex relationship that involves multiple subtrees. In terms of the absolute processing time, the HAS invalidation performs similarly to the traditional top-down invalidation when the relationship involves a single subtree. In case of non-subject HAS, the invalidation time is about twice as long, but it is reasonable considering the direction of the relationship. To control the processing time, we apply the cache that consumes a reasonable amount of memory that grows almost proportional to the tree height. So what will be the next? There can be more performance tuning, for example, for the relationship that involves multiple subtrees or for the multiple HAS on a single element. We can skip some unnecessary subtrees early by using the bloom filter, which was already applied in WebKit. Unless we have serious performance issues or functional issues, I think it is possible to enable HAS as a default feature, and I expect it to be possible within the second quarter in this year. Okay, this is all. Many thanks to Shtank and his team at IO for supporting this project, and big thanks to Ron for reviewing and guiding all the patches and approaches. Finally, thanks to all of my Igalia colleagues for reviewing, helping, and being a great team. Hopefully, HAS will be available in Chrome soon. Thank you.
Hi, this is Jose Apena from Igalia. I'm going to present a recap of last 2 years of work to keep GCC toolchain working. So right now, the only officially supported toolchain for building Chromium Linux is based on the Clang compiler and the least C++ standard library implementation from LLVM. There's no other toolchain supported officially on Linux. Why would you still be using GCC? People are using it for a variety of reasons and constraints, maybe because of an unsupported architecture, or a GCC-based toolchain tuned for a specific hardware, or just the need to link the components that only build with GCC. Same with lib standard C++, the newest tail implementation. Maybe the existing C++ libraries cannot be compiled with LLVM lib C++, or the fact that you cannot mix lib standard C++ and lib C++ libraries. This is important. My recommendation in any case is please move to use Clang and lib C++ if you can. What you can do for that is adding your C++ dependencies to third party, adding GN scripts to compile them as part of the Chromium compilation, fixing the build, and this is important. You only need to build the C++ current libraries and not the whole components. But meanwhile, GCC and lib standard C++ support are still maintained. Yes! Let's see how things are going. We have a metabug for tracking GCC support, 79 commits last year, 29 this year so far. The main problem we found with GCC last year are related to constant expressions, no except mismatches, Theme classes because of scope processing and braces initialization. This is the meta bug for tracking diff standard C++ support, 43 commits last year, 50 years so far. The main problems, diff standard C++ implicitly includes less headers, the copy and move requirements in STL types are different, and STL containers are not accepting const members in list standard C++. We are maintaining YouTube recipes for building the officially development releases of Chromium for Linux with GCC and list standard C++. We are testing it in Raspberry Pi 4 and Intel, both in 64 architecture. We are not testing 32 bits anymore. We are only testing Ocean support, especially with Wayland, and we just moved to use latest Yocto stable release, Keystone. Thanks to all the people that had last year's keeping things working, especially to Stefan Harman from Gentoo Community, our main contributor. So if you want to help, these are the links to check. Thanks.
Hi, my name is Kira Sievers, and I'm an engineer on the Chrome storage partitioning effort. Today, I'll be giving an addendum to my previous BlinkOn talk where I talked about storage keys, and today I'll be talking to you about the ancestor chain bit. So as a recap, I spoke to you about storage partitioning and the effort where we want to take APIs used for storage and communication and ensure that they are partitioned in third-party context by top-level content. And the primary way in which we do this is through an object we created called the Blink storage key. And the storage key consists of 4 parts: the origin of the page accessing the storage, the top-level schemeful site in which the storage is accessed, optionally a nonce, and then number 3, which we just added, and the topic of my talk today, which is the ancestor chain bit, which indicates whether the frame tree of the document has a cross-site ancestor. This is defined as a Majam enum, you can see here, and it can take 2 values. It can be k same site, which indicates that every single frame in the frame tree is the same site, including the top level site, or k cross site, which shows that at least one frame in the ancestor chain is cross site with the current frame, and that can include the top level site. So you might be thinking, well, this is interesting, but why did we want to create the ancestor chain bit? Well, prior to this, the storage key did not actually consider the whole frame tree of a document, and that left it vulnerable to clickjacking attacks. So in this example here, you can see we have in a top-level site, a.com, which embeds an iframe b.com, and that b.com is malicious and then encodes a.com again. This is a classic clickjacking, and to the average user, you might think, oh, this is all a.com. In the old storage key, if you were in that leaf node, would show you that the origin and top level were both the same. They would both be a.com, which is a problem. Now, with the new storage key with the ancestor chain bit, this would be then labeled as k cross site, because you can see we have that cross site ancestor b.com in the middle, and this would be rightfully partitioned that a2 from a1. This is helpful in the many scenarios, but for example, in the setup I described earlier, where you have A1 embeds B embeds A2, a service worker, for example, would have previously, without the ancestor chain bit, considered A1 and A2 to both be in scope. But now that we have the ancestor chain bit, we can label it as K cross site, and the service workers will consider A1 and A2 to be in different scopes, and different service workers will actually serve actions such as resolving promises and generating cipher cookies or accessing storage, so they're rightfully partitioned. So in conclusion, the ancestor chain bit is a new property of the Blink storage key that allows us to actually take into account the full frame tree of a document at the time of creation without having to store that tree in its entirety or calculate it at a different time. And this helps us further reduce potential clickjacking attacks as we continue to implement third-party storage partitioning. Thank you very much.
I'm Yoav. I work on speed metrics, and I want to talk to you today about task attribution. What is task attribution, you ask? Essentially, it's the ability to know that a certain JavaScript task was spawned by another task. And why would we want to do that? Well, there are a bunch of use cases. My main motivation was to create soft navigation SPA heuristics. So be able to know that a certain user click resulted in a URL change as well as in DOM modifications that then triggered paint. Another interesting use case is for input responsiveness beyond just the next frame. So right now for event timing, we keep track of the next frame that is presented on screen, but with task attribution, we'll be able to know of other frames presented on screen as a result of the input event that triggered the timing, and then be able to keep track of them. For long tasks, the number one feature request we've had for many years has been to be able to attribute them to certain scripts. So giving developers the ability to keep tabs on long tasks in the wild is something that task attribution will enable us to do. And finally, I think that there can be interesting applications when keeping tabs on what third-party scripts are doing, both for performance and privacy. And that would enable us to apply various policies on that front and keep third-party scripts accountable. And I suspect that there may be more interesting use cases around third-party origin trials, better ad interventions, user activations, and potentially more. So let me know if task attribution can help you solve a problem you're currently hitting. The current interface is one that enables you to get the current task ID and then check if another task ID is an ancestor of the current task. But the API is very mobile and likely to change to fit the different use cases as we develop them. And finally, task attribution works by assigning task IDs when scripts are executed or when callbacks are invoked, and then considering tasks that are created inside other tasks to be descendants of those tasks, and passing that info to V8 so it can properly tag new promises with the right task ID. So to wrap up, I think this can have interesting use cases across Chromium, and like I said, if this can help you, hit me up. Cheers.
Hello, I'm Kyung Kim from Igalia. In this talk, I would like to share an update on our contribution to the MPRG project since the last BlinkOn. First, let's remind the last update briefly. We had completed working on the pre-rendering content restriction. We had many added C++ unit and browser tasks as well as web platform tasks to ensure the restriction. Additionally, we had worked on the fixing long tail of MPRG tasks. For example, we have fixed code or features that should not trigger per non-primary page using using primary mainframe method. During this period, our team had landed over 100 CL for the task. As we were finishing the pre-rendering content restriction task, we began to shift to the pens frame task. Simply explain the pens frame imports a boundary between the embedding page and the cross-site embedded document to prevent user tracking or other private storage. In the next talk, presented by my colleague Minyoung Shin, she will explain the pens frame more deeply. We have modified the code with a test based on the decision on how to work on the pens frame. We have restricted to work on pens frame navigation where it needs like did start and finish navigation method implementation. And also, we needed to reconsider if restricting to a mainframe is what the existing code intends because a pens frame has its own mainframe. If the code that is restricted to mainframe should exclude pens frame as well as iframe, we have also excluded the pens frame by checking get parent or outer document method of random frame host class. Regarding the progress of the pens frame in MPR since the last BlinkOn, we have participated in working on the high priority pens frame task little by little since last September. And we started participating in the pens frame task in earnest the last October. We have helped to complete the priority task until the first deadline since then. Igalia team has landed over 180 CL since the last November. These charts show the number of commits related to MPRG and pens frame during the last 6 months. As you can see, Igalia has landed 181 CL regarding the pens frame task. Igalia take possession of about 31% of the total commit. We appreciate all participants who have worked on the transparent tasks in MPH during the period. Especially, we really appreciate the reviewers who have reviewed a ton of our CR with passion and deep knowledge. That's all to say from this talk, and thank you for listening.
Hi, I'm Myung Sim from Igalia. I'd like to talk about who is the main frame. We can have multiple pages with the main document and subframe in a single tab. We can have a top-level page, pre-render, PFCast, fence frame, portals in a single tab. Then, who is the main frame? The bottom line is all of these pages have the main frame. Please keep in mind that the main frame no longer just means the main frame of top-level page. We can know who is the who with each page's status, and we are keeping auditing a lot of Chromium code and correcting the wrong use right away as an MPH project. Let's take a look at two features that have made significant progress so far: pre-render and fast frame. When we make speculation rules, we create an invisible pre-rendering page. And when we expressly want to code that page, the pre-render page is activated. This is a diagram for the pre-render. It's important here to note that pre-render host has a separate frame tree from the top-level page one, so it can be managed independently from the top-level page. And another important point is module capability control mechanism to control web features to the policy, and pre-render navigation threshold to differ on navigation having cross-origin URL. When the pre-render page is activated, cloned navigation entry is inserted the primary frame tree, and frame tree nodes for mainframe and subframes are moved, and then the frame host is replaced and notify the pre-render page's activation to the renderer and observers. We may want to know the current navigation or the current frame host for which page status it is. During navigation, we can get it from navigation handle. After frame tree is created, we can get it from frame tree node or render frame host. Fence frame have a similar look and feel with iframes for user. Fence frame and iframe visually can compose together on the page, and fence frame also can have the nested fence frame and iframes. But fence frame are unable to communicate with each parent frame. And also, fence frame is unable to do it. This is the diagram for the fence frame, and it also has its fence frame tree like pre-render. We place the dummy frame tree node to avoid direct connection to each parent, so we can prevent directly access between them. We should clarify our intention, whether we really want to explore the inner tree or work out into out tree. We also may want to know the status for fenced frame, like the pre-render. We can get it from navigation handle, frame tree node, and then the frame host as well.
Hi everyone, my name is Benjamin, and I work in the accessibility team in Microsoft Edge. This lightning talk is about a new web primitive called Focus Group that my team and I have been working on for a few months. Before we get started, let's first focus on the current problem with keyboard accessibility. So, in order to make a website keyboard accessible, web authors must ensure that all focusable elements can be navigated to using only the keyboard. To that end, they basically have three options. First, they could set an access key on an element, but that solution is not really scalable and it's generally not a great solution. Second, they could set the tab index attribute with a value greater or equal to 0, which will create a tab stop to that element. Once again, if you have a complex web page like, let's say, Word Online that has dozens of controls, you don't want to make every element tabbable because it's just a bad user experience at this point. So they're left with the third options, which is a custom JavaScript-based solution that moves the focus using the arrow keys. This is what many web developers end up doing, but this solution is not accessible by default to screen reader users, and it can be time-consuming to implement. And this is where a new primitive comes into play. Focus Group allows arrow keys to move the focus between a predefined set of focusable elements. Let's take a look at a few examples to see how to use it. We have here a very simple list where all of the list items are focusable, but only the first option and the button can be tabbed to. Currently, we cannot move the focus to the other options using the keyboard, but as you can see, I can set the focus on every list items using my mouse. By simply adding the focus group attribute on the list element, we create a focus group that automatically includes all focusable children. These focus group items can be navigated to using the arrow keys. It's that simple. If we want to allow only the up and down arrow keys to move the focus in this list, we just have to add the vertical keyword. The same goes for the horizontal arrow keys with the horizontal keyword. If we want to move the focus from the last element to the first, and vice versa, we can simply add the wrap keyword to our focus group attribute. Focus group also works in more complex cases, like here, where we have seemingly multiple focus groups that all form only one big focus group. This is thanks to the extend keyword that we use. We also built another mode for focus group to work with grid type elements. Let's say that we have a table element and all of our cells are focusable. With the focus group attribute, you'll now have a super easy way to implement arrow keys navigation in your table. Just add the focus group grid and poof, it's done. So the next steps are to gather feedback from web developers. If you want to try it out, we're currently running an origin trial in Microsoft Edge, or you can simply enable the experimental web platform features flag in the flags page. We're also going to work with screen readers to implement a way to signal to screen reader users that the focus can be moved using the arrow keys. And then we're also planning on building a CSS version of that feature to allow for responsive design patterns under changing layouts. This was a really quick introduction. For more information, please Google OpenUI Focus Group and check out our explainer. Thanks for watching.
Hi. The protocol handler was part of the Chrome-specific codebase. Forking was the only way to use it, and patching Chrome the only upgrading mechanism. The new component makes the protocol handler logic Chrome-independent. The Chrome's delegate provides operating system integration as well as other Chrome-specific logic, like profiles management. Embedders may provide their own delegate implementation as well. The Chrome factory creates the appropriate delegate instance and a browser content that allows the registry to operate under incognito mode. These are the class moved from Chrome to the new component. The registry has been modified to operate without user preference storage, and the component provides a simple registry factory. This means no incognito mode and the use of a mocking delegate with no actual operating system interaction. One of the goals of this refactoring was to reduce code duplication of the privacy and security checks. We have moved all this logic to Blink, so that is used also by the new component. Additionally, we have moved all the security and privacy checks from the browser class in Chrome to the Web Contents IMPL class. This implies that any embedder that implements the Web Contents delegate interface shouldn't need to care anymore about these checks, assuming that any protocol handler instance is valid. As an example of use of this new component, we have implemented the registered protocol handler method in the content shell. All the Chrome-independent browser tests have been moved to the new component as content tests. The web platform test support is one of our primary goals. So far, only manual tests have been defined, mainly due to the user activation requirement and permissions prompt dialog. We would like to see more automated tests for this feature. The content shell implementation has been done with testing purpose in mind. That's why we have decided to avoid the user prompt dialog and bypass the permission APIs. However, we want to explore permission automation APIs available in some WebDriver implementations. So what's next? Secure context is a fundamental concept of the custom protocol specification. As part of the refactoring performed in this project, we pursue a unified implementation to minimize code duplication and improve inconsistency between render and browser processes. We have detected also different implementation of the same origin concept. The permission automation provides interface to query and modify the permission status using permission descriptor. Extension commands provide a communication protocol between the WebDriver and the browser. Not all the Chrome features that has permission policies have support for these permission automation commands. The custom protocols method add one of these features that lack support. The first task to support permission automation would be to define the permission descriptor mapping for the new custom handler permission identifier. Both Chrome and Content Shell rely on the Request Permission Manager, so we will need to adapt both implementations to check for overridden permissions. That's all. Thank you very much.
Hi, here's an update on the CSS highlight pseudos in Chromium. My colleague Rego and I have been implementing these features on behalf of Bloomberg. If you've got big ideas for the web platform, talk to Igalia. We can help. On the Blink side, the selection and target text pseudos are already shipped. The Edge team at Microsoft is working on custom highlights, and we've been working on spelling and grammar features, including the highlight pseudos and new text decorations. But most of our work has been in what underpins the highlights, in Paint, in Style, and in the spec. In Paint, we recently landed the new Highlight Overlay Painter. This is huge because it means we can now paint each piece of text exactly once, interleaving the backgrounds and decorations in exactly the right order. Assuming no new regressions crop up, hopefully this will ship in M104. In Style, things are a bit more complicated. Highlight inheritance is enabled for custom highlights, and we now have invalidation and DevTools support, but we're still working on performance issues and correctly handling cases where color is set to current color. Now you might be thinking, doesn't setting color to current color just mean inherit? And normally you would be right, but in the highlight pseudos, it means we need to grab the color from the next highlight overlay below. This is important for things like spelling errors, where we want to add a decoration without changing the text color, but it means that in highlight styles, we can no longer resolve colors until we know what's highlighted. That current color problem is one of many spec issues we found while implementing these features. The good news is that most of these issues now have resolutions, or at least proposed changes. After we enable the new Overlay Painter, we'll focus on the current color problem and the new spelling and grammar decorations. Once we get highlight inheritance performing well enough to enable it for all highlights, including selection, we should be able to ship spelling and grammar. For more details, check out these links, keep an eye out for our next in-depth blog post, or join us on Slack if you have any questions or ideas. Thanks!
Historically, document.domain has allowed cross-origin, same-site pages to script each other and share things like memory and WebAssembly modules. For example, the same-site pages a.example.com and b.example.com can both set document.domain to example.com to enable interacting with each other. The site-wide reach meant that when site isolation was introduced, it couldn't be origin isolation, since sharing requires the origins to be in the same process and JavaScript agent cluster. Recently, though, we've added support in Chromium for a new web platform header named Origin Agent Cluster. When this header is sent with a page, that page is isolated in its own origin-keyed agent cluster. This disables document.domain, and scripting and sharing are restricted to same origin pages in the browsing context group, or tab. Origin-keyed agent clusters have a number of benefits. First, document.domain can be a bit of a footgun, so disabling it is a win. Second, there are security benefits, since origin-keyed agent cluster pages can be process isolated at the browser's discretion. Renderer processes dedicated to origin agent clusters are called origin-keyed processes and provide additional security via the process boundary. But even if an origin-keyed agent cluster isn't process isolated, it still gets logical isolation within the renderer process. Finally, with or without an origin-keyed process, there are performance wins by decoupling the JavaScript execution between origins, like when mail.example.com and chat.example.com need to boost performance. But we need to keep things consistent even if the served headers aren't. So for the first time we see a page in a browsing context group, we keep track of whether it sent origin agent cluster or not, and if it did, whether it got an origin-keyed process or not. We then enforce that for any same origin pages that subsequently arrive in the tab. It's tricky keeping track of everything in an efficient manner, but it has its benefits. For example, it allows us to support origin-keyed agent clusters with some origins getting origin-key processes and others not, all at the same time. This flexibility will help with resource management in the long run. At present, relatively few sites send the header, and the process overhead of origin-key processes has been small. But soon, the web platform security team will be experimenting with turning origin-key agent clusters on by default. Of course, since some sites may still really need document.domain, they can opt out by sending a special header. Turning on origin-key agent clusters by default will result in a sudden jump in the number of isolated origins, so we'll only give origin-key processes to sites that explicitly sent origin agent cluster. but as time goes on, we hope to be able to give all origins with origin-keyed agent clusters an origin-keyed process, which will result in site isolation becoming origin isolation. A big thank to everyone who has contributed to all of this work, and a few additional resources for anyone who wants further reading.
Hi everyone, I am Michael from the Chrome Speed Metrics team, and I wanted to cover a new responsiveness metric that we are shipping more broadly and will become more popular over the next year, we hope. This new responsiveness metric is not a core Web Vital, but we do hope that it's on track to replace first input delay as a core Web Vital eventually. And for that reason, it already follows all the guiding principles for Web Vitals. It's designed to measure the responsiveness of discrete user interactions, such as tapping, typing on a keyboard, or clicking a mouse. It's not meant to measure continuous interactions like hover or scroll or stylus. Fundamentally, what it measures is the time from when the input is received, like you see on the left here, until the time that a frame is actually presented and displayed to the user, when pixels appear on screen. This is the end-to-end duration that is the first meaningful feedback that the user receives after an interaction. Nice and simple. And to help developers focus on how to improve this metric, we've broken it down kind of into three pieces. The input delay portion is any work on main thread that prevents event handlers from even running. This has been the primary focus for first input delay. Then you have all of the time spent in processing of event handlers, which is an increasingly growing amount of time, especially as we add JavaScript to the platform. And then there's presentation delay, all the work that comes after handlers run. You can have follow-up tasks, you can have very expensive rendering work, you can also throw just too much at the browser, which really delays the time until the next frame is presented. And developers are not always as aware of these costs, and so this just drives attention to what's important. We call it, for that reason, interaction to next paint, or INP, and there's this excellent blog post that just went out recently, web.dev/INP, where you can get all the details. Fundamentally, what you need to know is don't block next paint after interaction. Makes sense. This is fundamentally a field metric, and it measures, because it measures real user interactions, and so you can't just throw it at the lab and say measure my page and tell me how I do. You actually have to measure interactions with the site. There are things you could do in the lab to sort of automate interactions, which is a neat direction for lab tooling, but you can also use event timing, which is already exposed to Web Platform and is already shipping in Firefox, to just measure interactions. We added support to the Web Vitals JS library to make this easier for anyone who owns a site. We also already exposed it to the Chrome User Experience Report, or CRUX, and very recently it shipped to Paid Speed Insights by default. And so any developer who's using this very popular tool to get an assessment for their site will already see interaction to next paint in the bottom middle, as you see here. So this is chromium.org domain, and you can see the synthetic result thinks that we have a 99 out of 100 on performance score, but the real field data suggests that FID and interaction to next paint are not doing so hot, so we have more work to do. So it's important to measure real interactions. And for all of us who want to test locally, the simplest thing you can do is install the Web Vitals Chrome extension, which was just recently updated to add support for INP. And if you do that, there are additional developer features you can enable through the extension options that will help you when you're doing something like a performance profile recording. You'll get these nice timings, which will really help you visualize and narrow down your focus to what's important when it comes to measuring interactions. And with that, thank you very much. Have a great BlinkOn.
Hi, my name is Stefan Zager. I'm an engineer on the Blink rendering team, and I'd like to talk to you about flaky web tests. Web tests are extremely flaky, much more so than any other test suite in Chromium. At the same time, we still get important coverage from flaky tests, so disabling them is not a viable strategy. Web test flakiness is a tax on our continuous integration build resources, a drag on developer productivity, and an extra burden on build sheriffs, as recently highlighted in a lively discussion thread on Chromium Dev. A run of web tests consists of about 110,000 individual test cases, including virtual test suites. There are typically between 80 and 500 unexpected flakes per test run, depending on the platform, which does not include about 1,150 tests marked as flaky in the test expectations file. Altogether, there are about 300,000 spurious test failures per day across our build fleet. The reality is that web tests will always be flaky. There is no end to the struggle. Keeping the flakiness at a manageable level is not the responsibility of any one person or team. It is a collective responsibility. No one is exempt. In my personal opinion, spending 1 week out of your quarter working to reduce test flakiness would be an exemplary display of citizenship, if you know what I mean, and I think you do. And so, as surely as summer follows spring, it is time to rededicate ourselves to the problem of flaky web tests. But how do you make sure your efforts are not wasted? Given the scale of the problem, working on flaky tests can often feel like a low-value proposition. Here are some tips for getting the best bang for your engineering buck. Number 1, focus on reducing the total number of spurious test failures across the build fleet, because total failures is the most accurate proxy for productivity cost. The Chrome Ops team is hard at work on a shiny new flakiness dashboard, which for the first time displays a list of tests sorted by degree of flakiness. You can maximize your impact by focusing on the top entries in that list. Recently, I spent a couple of hours fixing the 2 flakiest web tests, which resulted in a 1% reduction in the total number of spurious failures across the build fleet. Hooray for me! You can make a difference. Secondly, work to reduce the number of flaky expectations in the test expectations file. Many of these entries were created by sheriffs, which is a strong indication that they are very flaky. These tests are especially problematic because they represent lost coverage. We have no way to tell when one of them starts failing deterministically due to a regression. Here are 2 concrete tactics. First, look for tests that are marked flaky but are actually passing most or all of the time. Delete those lines, instantly increasing our test coverage. Second, randomly remove a few flaky expectation entries and then commit yourself to following up on those tests after we have a few days of data from the builders. Happy hunting and onward for Chrome and country.
All right, so thank you very much for many amazing updates and heartwarming messages. So please send another round of applause to all the Lightning Talk speakers. Thank you very much. So if you are interested in some specific topics, so you can directly reach out to the speakers. So please do that. Great. So we will have another 13 Lightning Talks tomorrow. So see you tomorrow. Bye.
Oh my God, I've been muted this whole time. Sorry, y'all. So thank you, Kentaro, for that very cool run of Lightning Talks. As he said, we'll be starting the day off with Lightning Talks tomorrow. So we'll be starting at 7 a.m. or whenever you started the meeting today in whatever time zone you're in. I've got a few quick announcements. First, you can view your schedule at hopin.com/events/blinkon-16. This will list all of the breakout talks that are going on today and tomorrow. You can add them to your Hopin schedule or to your personal calendar there. The main stage sessions, such as the keynote presentation, the lightning talks and whatnot, can be accessed by the stage button. The breakout sessions will be accessed by the sessions button 5 minutes before their start time. You can follow along with the slides in any breakout session by clicking on the links in the session descriptions. And afterwards, you can view the recorded sessions on BlinkOn's YouTube channel. They'll be published by end of day, hopefully. And like I said, they will have human-generated captions at that point, just in case the automatic capturing doesn't work out great. Also, reminder again, you can enable closed captions within a session here, the automatic closed captioning, by clicking the CC button down below. And finally, you can network on Kumo Space at any time. This is something that people have been asking for a bit. We have it. It's a nice little positional chat feature. You might have run into similar things before. There are scheduled networking sessions at the beginning and end of each day, but you can show up whenever you want, anytime that you're checked out for a few minutes and want to chat with people. Hop into the Kumo Space and see who's around you can talk to. Okay, so coming up in about 10 minutes, 8:15 Pacific, will be the breakout sessions. For now, we'll have a short break to let you refresh your coffee or whatever else you're having to keep yourself fresh and ready for today. And then we'll resume for about an hour and a half or so of breakout talks in just a little bit. Thank you very much.